Welcome to the Algebra 1 Structure and Method textbook series. This is Chapter 8, Section 9, Direct Variation. Today we're going to use direct variation to solve some word problems, and before we get started, make sure that you know how to evaluate expressions using exponents and radicals, and we also need to be able to solve proportions. You're going to learn a few new words as well. For our warm-up, we're given some information and we need to write the required rate. Take a moment, pause the video, and restart when you're ready to see the answers. I will show the answers now. All right, let's start the show. This table is an example of direct variation. So it shows the mass m of a gold bar whose volume is V cubic centimeters. What do you notice about the mass as the volume increases? That's right. The mass increases as the volume increases. But also, if we took a closer look, the mass increases by 19.3 grams for each additional cubic centimeter of volume. This is an example of direct variation. When a function can be written as y equals kx, where k is non-zero, it's called direct variation. K is a constant that we call the constant of variation. And this relationship can also be stated as y varies directly as x and y is directly proportional to x. Example 1a. Given that m varies directly as n and m equals 42 when n equals 2, we need to find a, the constant of variation. Our first step is to set up the variation equation. So m varies directly as n, m equals some constant times n. Next, I'm going to substitute my values. M is equal to 42 and n is equal to 2. Then I'm going to solve for k, so I get k is 21. I'm going to put k back into my expression, and now I have an equation. M equals 21n. This is going to help me for the next part, which asks me for the value of m when n equals 3. So I already know that m equals 21 times n. All I have to do is substitute n equals 3 and simplify to get 63. Look at the graph of two quantities with direct variation. Most of the time, the quantities are positive, so the graph is in the first quadrant. It's also a linear function, so the graph is always a straight line. Now, when x equals 0 and y equals 0, when x equals 0, y equals 0. So this always passes through the origin. And the constant of variation, m, is the slope of the line. Now, if we consider 2 points on the line, x1, y1, and x2, y2, they both satisfy the conditions of being true in y equals mx. So let's go ahead and set that up. So y1 equals kx1 and y2 equals kx2. I'm going to isolate k for each. And since they're both equal to k, they are equal to each other. And this is a proportion, which is the reason why k is often called the constant of proportionality. And I'd also like to note, generally speaking, we use k. Some books will use m. I've obviously got a couple typos here, but we're going to stick with k for the rest of this video. Example 2. The amount of interest earned on savings is directly proportional to the amount of money saved. If $104 in interest is earned on $1,300, how much interest will be earned on $1,800 in that same period of time? Okay, again, I need to declare my variables. I'm going to make I my interest earned, always in the way, Cameo is always in the way, and D the dollars saved. I'm going to write my variation equation. My interest is directly proportional to the amount of money saved. So I equals K times D. K is the thing we don't have, and we're going to have various instances of interest and dollars saved. Next, I'm going to isolate K. So K equals I over D. Excuse me. And now I can set up my two ratios. I1 over D1 equals I2 over D2. Now all I have to do is plug in my values. So I my first interest is $104, dollars saved are $1,300. I won over $1,800, which is my dollars saved for the second scenario. And I isolate I1, I2, which is 144. So we learned 2 ways to solve direct variation equations in this video. Which one do you prefer? Turn and talk to your partner, and I will see you in the next video.